Okay, no issue, Chakrika. Yes, Abdullah. So what we learned that sound, it's a type of energy that travels in the form of waves. To understand how it works, you can imagine that you are dropping a piece of pebble into the pond, and it is going to create ripples, and that ripple will spread out in all the directions now. So similarly, whenever something starts to vibrate, due to the vibration, it will produce some sound. So when an object makes sound, like when you clap your hand or while I'm speaking, so it is creating vibrations in the air, and those vibrations spreads out as waves in all the directions. In this manner, the sound travels. And particularly, we learned that there are two types of waves. Mainly, there are two types of mechanical waves: the wave transfers and the longitudinal waves. Right now, so we learned that basically mechanical wave is a type of wave that will require a medium. There are different types of waves. In higher classes, you will learn about electromagnetic waves and all that. Electromagnetic waves are there, mechanical waves are there. Electromagnetic waves, by the way, light is a type. Light is an electromagnetic wave. Light travels in the form of electromagnetic waves. Gauri and Abdullah, you guys turn your cameras on in the class. If there's some network issue, if you guys are traveling or at some other place, if there's some.
Sir, I'm actually traveling, so I can't.
Okay. Gauri, what about you? So what are we saying now? A mechanical wave, it's a type of wave that requires a medium. Before this, I was saying about the electromagnetic waves. While you will be learning about light, you will learn that light is a type of electromagnetic wave. Electromagnetic is a type of wave that does not require any medium to travel. But mechanical wave will require a medium. Right? Medium could be air, water, or solid. And it cannot move through the vacuum because it will rely upon the particles in the medium, and those particles will carry the energy. Getting my point, guys? That is something which we have learned. So energy will be transferred from one particle to another in that medium through vibration. One particle will vibrate, it will make the other particle vibrate. If it is air, this is 1 minute. See, the medium is air. So in this, how the energy will be transferred? So if one particle will vibrate, it will make the other particle also vibrate. So in the form of by vibration of the particles, energy from one place to another will be transferred, whether it be air, whether it be solid, or the gas, or the liquid medium. So we learned that there are two types of mechanical waves: transverse waves and longitudinal waves. In the case of transverse waves, what we have learned that the particles of the medium will be moving perpendicular to the direction of the wave. You guys can look at this animation, that will give you a very better clarity. Look at this animation, everyone, carefully. So here, you guys tell me what you guys are observing here. The motion of the particle of the medium, isn't it perpendicular? Like this?
Yes,
they are perpendicular, isn't it? Chakrika, Gauri, everyone, Abdullah. Right now. So that is the case of the transverse wave. Another one is the longitudinal wave, in which the movement of the particle of the medium is parallel to the direction of the direction of the wave. Here also you can look at the transverse wave. This is also the example of the transverse wave. Okay, no? Like the fans are jumping in this manner. Okay, no? The Mexican wave. So they are jumping in this manner. So you can understand it in this manner. Now take a look at the longitudinal waves, in which you will see that the particles of the medium are moving parallel to the wave motion. Motion of the wave is like this, and the medium is also moving like this. It is moving in the form of contractions and rarefaction. So that is something which we learned, and we will also learning about time period and frequency. Today we'll be learning about amplitude also. Okay, now so let me just quickly revise this topic. In the case of frequency, we learned that the number of waves that will be produced in 1 second, it is called as frequency. What we have done, the number of waves, or we can say number of vibration or oscillation that will be done by any given object in 1 second is called as frequency. So frequency was calculated by using this formula. Frequency is equals to number of oscillation upon time. Frequency equals to total number of oscillations upon total time taken. A total number of waves produced upon total number of time taken here. All of these are used exchangeably here. Whether we say oscillation or we can also say number of waves produced in 1 second. The unit is hertz. So can we say that 1 hertz will be equal to 1 hertz will be equal to number of vibrations produced in 1 second? Yeah.
Yes, sir.
Can we say this? Yes, Chakrika, everyone.
Yes, sir.
Yes, sir.
Okay, no, that is okay. Further, we learn that if the number of oscillations are more, if the number of vibrations or number of waves produced are more, so thereby the frequency will be more, right now, isn't it? So take a look at this one here. So here the number of waves produced is more, so thereby the frequency will be high. And here, let's say that the time taken to produce these number of waves, let's say we are taking same time here. We are considering that this is also 1 second and that is also 1 second. So in the both the situations, let's say that these are two speakers and these are the sound waves produced by these two speakers. So the waves produced in 1 second by this speaker is more and here it is less in the same given time. So thereby this one is having a low frequency, this one is having a high frequency. So that is something which we have done. So you guys tell me 1 hertz will be equal to how many, will be equal to what? Yeah, tell me 1 hertz is equal to?
Sir, can you repeat?
1 minute. I was saying that 1 hertz is equal to how much? How do you define this? Yes.
1,000.
No, not 1,000. I
1
didn't say that.
second frequency.
One complete oscillation or one complete vibration upon 1 second, basically. Right now, 1 hertz will be basically equal to 1 vibration per second. Getting my point now. 1 hertz basically it means that one complete vibration in 1 second. One complete vibration in 1 second. Remember the frequency of the pendulum when you had to find the frequency of the pendulum, for example. So
Sir,
how do you yes?
in our school, like this chapter is not there in our portion.
Sound is not there in the syllabus.
Yeah.
Okay, if it is not there, so there.
Neither do I have it.
Chakrika, repeat again.
Sir, neither do I have it.
You have it.
So no, sir. I don't have it.
Okay, okay. Gauri, what about you?
Sir, which portion they're talking about? Finals?
No, they are talking about this chapter, sound.
I don't know, sir. They didn't give a syllabus right now.
Okay, but in the updated syllabus, this chapter is there actually. Thereby, I took up this chapter. Okay, now. Okay, let's do one thing. Gauri, kindly check your syllabus. If in your school, you haven't got the syllabus from the school yet.
Yes, sir.
Okay, but you must be having some book which your school your school must be following.
Yes,
Sir,
sir.
I also didn't got my syllabus, but I asked my science in school. He said that this sound chapter is not coming.
It's not coming. Okay, it is not coming. Neither it is coming for you, Chakrika. Okay.
Sir, basically, it's not even in the textbook. So
Okay, that is the case. Gauri, what about you?
So
As you
this
told me.
chapter, it is in my textbook, but teacher didn't say like this will come or no.
Achha, okay, that is the case. Okay, if that is the case, there are other students like Gauri, Roni, and Aleph also. I will have to confirm with them also. Okay, na? I will have to confirm with them also. So let's do one thing. Let's do one thing now. We can either wrap up the chapter quickly, Okay, because we have already covered about 75% of the chapter. 60 to 75%, I think we have covered in the chapter. Few things are left to be done in the chapter. Okay, no? So we have two choice. Either we can wrap up the chapter quickly, since I don't think it would be proper to leave the chapter in the middle like this, because these concepts, nonetheless, they will be helping you guys in your higher classes. Okay, no? Anyways, you have to learn about frequency, about time period, about amplitude and all that. Getting my point? What I'm trying to say. Or we have yes, Chakrika.
No thanks, sir.
Mm-hmm.
Sir, I was just saying yes.
Yeah. Okay, no. So I will be quickly wrapping up the chapter then, if it is not there. Okay, no? Because I don't think it would be nice to leave it in the middle. Okay. So we learned about frequency. Frequency is basically how many vibrations or how many oscillations are being done in 1 second. Are being done in 1 second. And the unit of frequency is hertz, right now. So 1 hertz will equal to 1 complete vibration or oscillation in 1 second. 1 second. That is one thing. Like for example, take a look at this here. So in this, you can look at this, how many waves are being produced in 1 second, right? And in this one, also waves are being produced in 1 second. So that will basically tell us about that 1 hertz is equal to, let's say, 10 vibrations being done in 1 second. So the frequency of that body will be 10 hertz. If 80 vibrations are being done in 1 second, so thereby the frequency will be 80 hertz. Getting the thing. Further, we learned about pitch also. So pitch it's one of the quality of the sound. Like sound has different quality. Loudness is the quality of sound. So pitch is also the quality of sound. Yes, Khadija, how are you? So pitch of the pitch of the sound, it allows us to perceive its frequency. By pitch, we will get an idea about the frequency of the sound. Khadija, do tell me one thing that first of all, please try to join the class on given time. And secondly, the chapter sound, is it there in your syllabus? Is it being taught or will be, has it been, is it there in your syllabus or not?
Sir, I'm not sure. They didn't tell us yet.
Okay. You haven't got any update on this chapter from this school?
No, sir.
Okay. Do one thing, particularly Gauri and Khadija, you guys, when you go to the school, kindly confirm from your teacher whether this chapter will be coming in the exams or not. Okay.
Okay, sir.
Okay, sir.
Both of you update me on this on the next class. Okay, no? Okay. So if a sound has a high frequency, the pitch will be high. If a sound has low frequency, pitch will be low. So there is a direct relation between pitch and the frequency. That is one thing. So for example, you might have seen a soprano singer, or you might have seen the YouTube videos of a soprano singer, or when a whistle is blown. So all these sounds have a very high frequency. So they will be kind of giving a tingling sensation in the ears. Might not be very pleasant to hear. Right now, if a sound has a very high pitch, or when we see that, if for example, the barking of the dog, it is not pleasant because the barking of the dog has a very high frequency. Right now, so it is not very pleasant. But on the other hand, a frequency with a low frequency has a low pitch. So for example, a bass drum or a deep voice, they have low frequency, but they are more pleasant to hear. Getting my point, what I'm trying to say? Then we learned about the time period also. So time taken by an object or the particle to complete one oscillation is called as the time period. Will be called as time period. It is denoted by capital T, and the SI unit of time period is second. And time period is calculated by dividing the total time taken upon the total number of oscillation or vibration done by the body. Okay. Suppose, for example, let us say that there's a sound wave that is doing some vibrations. Let us say that in 10 seconds, it did 5 oscillations. So thereby the time period of the sound wave will be 2 seconds. Getting my point out. So that is how we calculate the time period. Further, we know that the time period and frequency, both of them share an inverse relation. They have an inverse relation, and they are shown by this relation. Time period equals to 1 upon frequency. So time period is inversely proportional to frequency. If frequency is more, time period will be less. If this is more, time period will be less. Or if frequency is less, the time period will be more. So that is the relation which they share. Another thing which we have to learn is the amplitude. So amplitude in very simple terms we define as the height of the sound wave. As you guys can see here, look at the height of the sound wave here. Okay, now? And this will be showing you strong or how intense the sound is. If the amplitude is very high, meaning if the height is very high, so thereby the sound will be louder. If someone has a very loud sound, so when I will be drawing the graph of the sound, when we will plot it, when we will draw the wave of the sound, so we will find the amplitude of the sound will be very high. Or if someone has a very low voice, thereby the amplitude will be shorter. So amplitude, what does it determine? It determines the pitch of the sound, or does it determine the loudness of the sound? Yes?
Loudness.
Loudness, no? So higher the amplitude, higher will be the loudness. That is one thing. Okay, so we have learned
Sir,
about, yes,
so what's the difference between pitch and loudness?
pitch and loudness. Okay, pitch is basically pitch is the property of the sound which tells us about the frequency of the sound wave, while the loudness is another property of the sound which tells us about the amplitude of the sound. Getting it now?
Yes.
Both of them are the characteristics of the sound. Both of them are characteristics of a sound, but there's a slight difference between pitch and loudness of the sound. Okay, so pitch will be, or also they differ on the quality also. The tone quality is different, right? Now that is one thing. While pitch will be depending upon the frequency, while loudness will be depending upon the energy of that that is being carried by the wave. If the energy being carried by the wave is more, so thereby the amplitude will be more. Right now, that is one thing. Also, we get to see that there's another relation between the there's a relation between the two also. Okay, there's a relation shared between them two also. Meaning that, for example, if the pitch will be decreasing, loudness increases, or if pitch increases, loudness decreases. So they share an inverse relation. Getting point what I'm trying to say?
Yes, sir.
So that is the thing. Okay. We have some questions to do, but as you guys are saying that this chapter is not there, so I will be skipping this portion as of now. Okay, because majority of you are saying that this chapter is not there in the syllabus, but for some of you, I think as I went through the syllabus, for some of you it was there. Nonetheless, we have another important topic, that is audible and the inaudible range of the sound. So we humans are able to hear the sound that is a frequency between 20 hertz to 20,000 hertz or 20 kilohertz, and that is known as the sonic range or the audible range of the sound. Below 20 hertz, it is inaudible, hence it is called as infrasonic range, and above 20 kilohertz or 20,000 hertz, it is ultrasonic range, or also called as ultrasound. Now, with the help of the ultrasound, there are some applications of the ultrasound waves. Okay, now there are some applications of ultrasound waves in the field of medical. It is used, okay, na, in order to create images of the different tissues inside our body. Ultrasonography is done. As we can see here, the ultrasonography is being done here. So what happens here, as the sound waves will be reflected from the tissues of the body, so thereby the image is created. As the sound waves will be reflected from the parts of the body, so thereby a image will be created. Getting it now? So not only it is helpful in detecting the growth of the fetus in the womb, but also in order to detect for the disease in the body, or in order to look at the internal structure of the body, we can it is done right now. In the case of echocardiography also, where we create the picture of the picture, where we can generate the picture of the heart, okay, and it will determine us if there is some formation of clot in the arteries, or if the heart is functioning properly or not. It can be done. You might have heard of the sonar, SONAR. It's a device with the help of which we can determine the depth of the ocean, right? Or we can measure the distances between the objects that are very far away from each other. You might have heard about radar and sonar, all these things, or haven't learned about this. So there are several applications. So one of the application, as I was saying, that it is in the case of the imaging, ultrasonography, basically. Ultrasonography. Another application is in sonar. Where is sonar technology used? Sonar technology is used in order to determine the depth of the oceans. How will it be done? Suppose we are on top of a water body, say on an ocean. So from here, the sound waves will be sent. And as the sound wave will be hitting the bottom, and as it will be returning back to the surface after being hit from here, so the time it will take in order to reach this, with the help of that, we'll be able to calculate the distance or calculate the depth of the ocean. Getting my point, what I'm trying to say? So that is one such application of this. There are some other applications also. Like for example, if there is some construction work which is going on, or if suppose there's a dam or there's a bridge, and if there is some crack which has developed in that bridge, or suppose some building, but it is not visible to us. From outside it looks fine, but inside the structure there are some cracks which have developed. So with the help of the ultrasound waves, we'll be able to detect that crack. Getting what I'm trying to say, guys? So
Yes,
it has a wide range of uses. So to detect cracks in buildings, dams, etc. That is one thing. Now we know that there are some animals that can hear sounds of frequency higher than 20,000 hertz. Dogs have this capability. So thereby, the police would be using high frequency whistles which dogs can hear, but the humans cannot. Okay, no? So that is one thing, such thing. And the ultrasound equipment familiar to us for investigating and tracking any medical problems, they also work on the frequency that is more than 20,000 hertz. That is one thing. So these are some of the applications. Now there is another thing, that is the hearing impairment. So different people would be suffering from loss of the sense of hearing. The reasons could be there could be different reasons for this. Total hearing impairment, which is very rare, it is usually from the birth itself. The child is born in such a way. Partial disability is generally the result of a disease, injury, or age. One can lose the sense of hearing. They can lose the sense of hearing partially, either due to some disease or some injury to the inner part of the ear or the middle part of the ear. Children with impaired hearing, they need special care, and by learning the sign language, such children can communicate effectively, because speech develops as the direct result of hearing. Like our speech develops, we talk when we hear. If a child from the very beginning does not hear anything at all, his speech will not develop. Getting my point now? Suppose there's a person born on the island, and that island, there's no sound being produced in that island. There is no birds, no animals are there, nothing is there, no person is there. So will the child develop the sense? Will that child develop speech?
No, sir.
no, no,
No.
sir.
If he or she hasn't heard anything, so how will they develop it? So speech develops as a direct result of hearing. So a child with a hearing loss may have defective speech also. They will be having trouble in speaking also. So, but nowadays there are technological devices which have made it possible for those persons to hear, or and with the help of this, they will be able to improve their quality. And we humans, we people as a society can also improve their living condition by helping them wherever possible. So that is one thing. Another things which we have learned in the chapter, like sound travels slower than the light, right now. So there's a huge difference between the speed of loud light and speed of sound. Now we know that there is in the case of the sound, what in the case of light, what we have learned. What is the speed of the light? Yeah, what's the speed of the light? Yes, isn't it obvious? 3 lakh kilometer per second. Now? That's the speed of light. So 3 lakh kilometer per second.
2,99,000.
Yeah, to be specific, we can take that in decimal also. By the way, when we will look at the speed of the light in the in air or in vacuum, where will it be faster? In the air or in the vacuum?
I think
Sir,
the perfect.
Yeah, continue one after another. One of you say.
Sir, in
Sir,
vac-
can you repeat your question?
Okay, Chikrika, you're saying this actually. Okay. My question was that the speed of light is more in vacuum or in air?
The speed of
Speed of light is more in vacuum or is it more in air? Chikrika, the answer is not correct, by the way.
sir air.
Vacuum actually. Okay, now the speed of light is more in vacuum. Keep that in mind. Okay, that is one thing. So speed of light is 3 lakh kilometer per second. And also when we talk about the speed of light in vacuum, so it is more as compared to the speed of light in air. That is one thing. Further, when we talk about the speed of sound, it will be differing with respect to medium. And as we have learned that in which medium the speed of sound will be maximum?
Vacuum.
Solid.
Solid, no. Solid.
I heard wrong, sorry.
Okay, no issue. So in solid objects, particularly in materials like iron or in steel, the speed of the sound will be about 5,000 meter per second. It is 5,000 meter per second. In water, it's 1,500, and in air, it's 340 meter per second. That is one thing. Okay. So from this table, the speed of sound in air is 340 meter per second. Okay. And as we can see here, it is in the increasing order. Okay. Now, if someone were to ask, how can you prove that sound travels slower than air? So we see that light, whenever there's a thunderstorm, so lightning will be seen first. So you will first see the flash of lightning. Flash of the lightning is seen first, and the sound of the thunder is heard a little later. Got this, no? So that is one thing. So because of the very high speed of the light, we are seeing the flash of lightning first, and then later we see this. That is one thing. Now, apart from the medium, there are several factors that determines the speed of the sound in a given medium. There are several factors that will determine. Like the speed of the sound will depend upon the density of the medium through which it is traveling. If the density is, if for example, the density is low, okay, na? So sound will be traveling faster in that medium. In generally, what we know that sound travels faster in the solids, now, isn't it? Sound travels
Sir.
faster in solids and with lesser speed in liquid and with slowest in the air. So there are several factors that will determine the speed of the sound other than the medium. So that is one of the thing was, as I was saying, that it's the density of the medium. Then it's the temperature of the medium also. So when the medium is then, what we know that the molecules of that medium, they are closely packed into each other. So this will mean that sound will travel faster in a denser medium. It will travel faster in a medium. So the factors that determine speed of sound, other than the medium I'm talking, we have already learned about the medium. Okay, na? So one thing is the density. So a medium that is more dense, in a medium that is more dense, the speed of sound is more. Speed of sound is more. Why is it so? Because the molecules of that medium, the particles of that medium are compactly packed, they are closely packed. Getting it now? So because of which the speed of the sound will be traveling faster in this, it will increase. So as the density of the medium will increase, so thereby the speed of the sound will be increasing. And that you can understand from this also. If the given medium is air, if it is liquid, and then if it is gas. So isn't the density increasing from gaseous to liquid to solid? As we go from gas to liquid and then to solid, the density is increasing or is it decreasing?
Increasing.
So it is increasing, thereby the sound speed of the sound increases. Another factor is temperature of the medium. Okay, na? So the speed of the sound will be directly proportional to the temperature. So as the temperature will increase, the speed of the sound will be increasing. Getting my point now? So it's the temperature. So speed of sound is directly proportional to the temperature of medium. The temperature of medium. Hope this much should be clear to everyone. Okay. Another basic thing is basically noise and music. So the difference is that any kind of sound that is unpleasant over here to our ears, so that is noise, and the sound that is pleasant to hear is basically the sound produced by the musical instrument. It is music. So when we look at the waves produced by the noise pollution, so it will be kind of looking like this. Take for example, look at the second wave here. So the wave is not even, it is not a smooth. So this is the wave produced by a noise. And a pure note, basically a sound which is produced by a musical instrument, will be like this. Getting my point out? And all other waves are telling you about different characteristics of a sound. Like if a sound is a loud, so we know that the amplitude is more. A loud sound has a more amplitude, isn't it?
Yes,
If the
sir.
if the amplitude is more, so thereby the loudness will be more, because loudness is determined by the loudness is determined by the amplitude of the sound, and the number of waves are also more here now, so thereby the pitch will also be more. And now here you guys take look at this one and tell me, is the amplitude more as compared to the first? This one, is the amplitude more or less? The amplitude basically
Less.
it's less now. It's basically, you can understand it as the height of the wave here, height of this. So the amplitude is less, so thereby it is soft sound, right now. But the frequency is more, so thereby the pitch is more. And in this one, we see that amplitude is more, but the number of waves produced are less. And if there is less waves being formed, so thereby less vibration means that the pitch will be low now. Less frequency means pitch is low. So that is the way how we can understand this. Now there are different problems that occurs due to noise pollution. Due to noise pollution, people can suffer from several health problems like insomnia, lack of sleep, or hypertension. The blood pressure can increase, or in certain situations, persons can also lose their sense of hearing or can also suffer from anxiety. And sound also, while we were learning about this amplitude now, so there I did told you about the loudness, right? The loudness of the sound is determined by the amplitude, and loudness is measured in decibels. In decibels, loudness is measured in decibels. So the unit of loudness is decibel. Keep that in mind. Getting it, guys? So that is one thing. Okay. So any sound that has a loudness more than 80 decibel. Decibel in short is written as small d and capital V. So any sound that has a loudness more than 80 decibel is painful to hear. And a person who has been exposed to loud sound for a very long period of time, they can suffer from temporary or permanent impairment or of hearing or loss of hearing. That is one thing. So what are the ways to control the noise pollution? So there are different ways to control. Like for example, we can control the noise pollution in the traffic areas, in the road, by planting more trees, as the leaves of the trees would be acting as the cushioning material and will be reducing the sound waves. That is one way. Or we can control the source, basically the machines or the vehicles from which the sound is being produced. So we can produce them in such a manner at the industrial level. We can manufacture them in such a level that they do not produce a very um, they do not produce noisy sound like this. That is one thing. And there are different sources of noise pollution. It could be coming from the traffic noises. It could be due to some construction works like drilling or hammering, and other construction activities will produce sound. Loud sound being produced by the machineries in the factories or at workshop, that is also the source of noise. Loudspeakers, music, or the air traffic also, like the traffic generated from the aeroplanes or the jet aircrafts, that also will produce the sound. So these are the different sources of the noise, I mean to say, basically. And these can lead to insomnia, it can lead to the hearing loss, and it can lead to anxiety, stress, etc. So that needs to be controlled. So there are different methods to limit the noise pollution, like use of barriers like planting the trees and building soundproof walls around the noisy areas, like particularly highways or factories, can help to reduce the noise. Or use of curtains at homes can also help in reducing the noise. Or we can control them at the source, meaning that the source of the noise, basically it is different kind of machinery, different kind of vehicles. So there we can manufacture them in such a manner that they don't produce that much of noise. We can use soundproof materials, like we can install soundproof windows and doors in our buildings to block the outside noise. Or we can use curtains and carpets and other soft materials that will be absorbing the sound waves. Okay, now that is also, so there are different ways to control the noise pollution. Or if someone is using loudspeaker, they should be limiting the use of loudspeaker. So that's it in the chapter. There is one important thing. I think we haven't learned about the functioning of the ear, no? As the sound travels through the ear, what exactly happens there? So for that purpose now, first of all, we will take a look at this animation here. What exactly happens as the sound waves will be traveling through our ear. So ear, that is the sense organ, it helps us in hearing sound. So what happens if you were to look at the shape of the outer ear here? So the shape of the outer ear here is like a funnel. You guys understand the funnel, no? FUNNEL.
Yes.
So it is shaped like a funnel. So outer part of the ear, this is being called as pinna. We call this as pinna. Okay, now that is called as the pinna, and it is attached to about 2 to 3 centimeter long canal called as ear canal. So this ear canal, it is 2 to 3 centimeter in length. Getting now? That is something. Now at the end of the ear canal, there's a thin elastic drum called as eardrum, and it is stretched tightly. It is stretched tightly inside our ear. Now, after that, you can see that there are 3 small delicate bones here. There are 3 small delicate bones. It might not be visible, so I will be highlighting this one. This is the first bone. This is the second bone. And that here is the third bone. Let me see this one. Hope you guys can understand. I have shaded it using different colors. Okay, now? So there are 3 tiny bones just behind the eardrum, and they are very small and delicate bones, and they are namely called as hammer, anvil, and stirrup. What do we call them? Hammer, anvil, and stirrup. I'm writing it over here. As you guys can see here, see this, and this. So hammer, anvil, and stirrup. Okay, and all of these will be vibrating. They vibrate. Okay, now we will learn how they will be vibrating and how sound will be produced and etc. So the ear bones, there are three. The first one, as I have highlighted, is hammer. Next one is anvil, and the third one is the stirrup. Okay, hammer, anvil, and stirrup. Now, hammer, anvil, stirrup are present in the middle part of the ear. They are present where? They are present in the middle part of the ear. This part of the ear that we can see here, that is the middle part of the ear. And this ear canal and the ear pinna, that makes up the outer part of the ear. What do they constitute? They makes up the outer part of the ear. All of you able to understand this now? That's the outer ear.
Yes, sir.
And from here to here, from here till here, that is the inner ear. Sorry, inner, basically, we call this as middle ear. That is the middle ear. After the middle ear, whatever is present here, that is called as the inner ear. That's the inner ear. Now let us understand what exactly happens here. As you guys can see in this animation here, that the ear pinna that is shaped like a funnel, it will help in catching the sound waves, and those sound waves will travel via the inner canal. And as you guys can see here, it is hitting the drum. So the drum will start to vibrate. The eardrum is going to vibrate now. And as a result of vibration of the eardrum, you will see that these bones will also start to vibrate here. So due to the vibration of the ear bones, the sound is amplified further. The sound is being amplified further. Getting my point now? So the function of the ear bone is to amplify the sound. In loudspeakers and in different sound devices, there's a button called as amplifier button. With the help of an amplifier, you can increase the volume. So something similar is happening here. Due to the vibration of the bones here, they will get sound wave will be amplified. So sound, first of all, will be traveling as the form of waves into the ear canal. Okay, and as it will be going into the ear canal, it will make the ear drum to vibrate. And these vibrations are transmitted to three small bones in our middle ear. Okay, and hammer, anvil, and stirrup. Actually, when you look at this hammer, the first bone is shaped like a hammer. That's why actual name of the bone is malleus. But since it is shaped like a hammer, so we are calling it like this. The other one is incisors, and the third is stapes. These are the names given to the shapes of these bones. Hammer, anvil, and stirrup, these are the names given to the shapes of the three bones inside our ear. But the actual scientific name of these bones are malleus, incisors, and stapes. You guys getting the distinction between the two?
Yes, sir.
Yeah. Hammer, anvil, and stirrup, they are the name given to the shape, while malleus, incision, and stape, they are the actual name of the bones here. Now they will start to vibrate and it will further amplify the sound. So far, it should be clear, I suppose. Now, after this, what will happen now? After this, we will see that in the third part of the ear, in the inner ear, we will see that at the end of the stapes here, we will see that those sound waves are being passed on to the inner ear, and there we will see that we have a structure. This structure in the inner ear that is called as cochlea. What do we call this? Cochlea. This whole structure. Let me highlight this. This whole structure that we are seeing over here, that is being called as cochlea. Cochlea. Okay. So this cochlea is actually filled with a liquid. This is filled with a liquid. That is being filled with liquid. Okay. And one end of the cochlea is being connected, as we can see here in this diagram also. One end of the cochlea is connected to the stapes here. Okay. So one end of the cochlea is connected to the middle part of the ear through this structure called as stapes. And this is filled with a liquid. And the liquid that is present in the cochlea, it contains the nerve cells, which are very much sensitive to the sound. The liquid present in the cochlea contains the nerve cells. So it contains nerve cells that are sensitive to sound. So what will happen here now? Also, one more important thing here. When we look at the other end of the cochlea, it is connected to a nerve called as auditory nerve. We call this as the auditory nerve, which is connected to the brain. This auditory nerve goes to the brain. That is one thing. So what is going to happen here? As the three bones have vibrated in the middle part of the ear, they will be kind of acting as a system together. They will be amplifying the sound vibrations that is coming from the eardrum, and it will be then passed on to the inner part of the ear, that is to the cochlea. Now, in the cochlea, what will be happening? What kind of nerves are present here? You guys tell me. What kind of nerves are present in the cochlea? They are nerves which are sensitive to sound now, as I told you. There are
Yes,
nerves
sir.
present inside it which are sensitive to the sound. Now, what will happen as the vibration from the bones will go to the cochlea? So the liquid inside the cochlea will start to vibrate. The vibrating stirrup here, that is the last bone called scientifically called as stapes. So the vibration from this will passed on to the liquid of the cochlea, and as the vibration will be passed on to the liquid of the cochlea, so the vibrating liquid of cochlea will set up electrical impulses in the nerve cells present in it. Electrical signals will be produced. Getting it what I'm trying to say? Electrical impulses will be produced in this, and these electrical impulses will now be carried by the auditory nerve to the brain, and the brain will interpret these electrical signals as sound, and thereby we get the sensation of hearing. Hope you guys are able to understand this. Let me take a bigger diagram to sum up the whole thing which we have discussed here. You guys tell me if anyone has a question in this, please let me know. What are the three bones present in the middle ear? Yes. Okay. Yes, that is hammer, anvil, and stirrup. Okay, now guys. Now what is happening here? Let me sum it up. As the sound waves will be traveling in the outer part of the ear, this is the outer part of the ear. Those sound waves will be hitting the eardrum. This is the eardrum that is being hit. And there are three bones here: malleus, incisors, and the stapes. Also, they are called as hammer, anvil, and stirrup. They will start to vibrate. And this structure that you are seeing here, this coiled structure that is being called as cochlea. And what is it filled with? It is filled with some liquid that has nerves which are sensitive to light or sound. What is it sensitive to?
Sound.
Sound, no? Yeah. So as the vibration from these vibrating bones will be passed to the liquid will start to vibrate. As the liquid inside the cochlea will start to vibrate, now as it will start to vibrate, so thereby it will generate electrical impulses. The vibrating liquid of cochlea, it sets up electrical impulses in the nerve cells present inside it. Okay, and now these electrical impulses will be carried out by these nerves are basically together, they are called as auditory nerves. These are the auditory nerves. So auditory nerves will be carrying those electrical impulses. If you're getting confused in impulse, you can just understand this as the electrical signals. These are the electrical signals which will be then going to the brain, and now your brain will be interpreting it. The brain interprets those electrical signals, and we get the sensation. It will be interpreting it as sound, and then you will get the sensation of hearing. Is the structure and the functioning of the human ear clear to everyone or not? Please let me know.
Clear, sir.
Okay, Abdullah, Chakrika, you
Yes,
guys,
sir.
it is?
Yes, sir.
Okay, no, that is the case. Okay, then. There are a few questions. I will be asking some questions from this, and then we're going to end the class then. You guys tell me, what is the relation between time period and frequency? Yes,
They are inversely proportionate to each other.
proportional, you should be saying.
Yeah.
Okay, no? Or we can say that time period is basically equal to the reciprocal of itself, reciprocal of frequency. Okay, that is one thing. So say for example, if I were to give a small question to you guys, say that if the say that question is that if the frequency is 10 hertz, so what will be the time period? Isn't it very easy to find? Frequency is 10 hertz, the time period will be equal to how much? As you guys know, that relation is time period equals to 1 upon frequency. So using this, simply calculated. Yes, is
Sir,
it
decimal 0.1.
0.1 exactly? No, so that is 1 upon 10 equals to 0.1 second.
We
Very good.
can as 1 second.
We can
Say as 1 second.
no, we can't say it as 1 second. It is 0.1 second. It is 0.1 second. Okay, no, so that is the case. Okay, now you guys tell me, the loudness of a sound depends upon frequency, or does it depend upon amplitude?
Amplitude.
On
Sir,
the
amplitude.
amplitude. Very good. Okay, so a feeble sound will be having a higher amplitude or low amplitude? A feeble or a faint sound
Lower.
will have a low or a small amplitude. Good. Okay. Also, there are some other things I wanted to say, that as we were talking about loudness, so as we are breathing, the normal breathing, when we are breathing at a normal rate, so the sound that is produced, that is 10 decibel. Normal breathing,
10 decimals.
10 decibels. Okay. Or if we were to whisper in the ear of someone, at that time, the loudness of the sound is about 30 decibel. Whispering has 30 decibel of sound, etc. Like this. Okay. Or like as we are having a normal conversation, so the normal conversation as we are having right now, so at that time, the loudness of the sound is about 60 decibel. Okay. And at a factory, usually the loudness of the sound will be about 80 decibel, and above 80 decibel. Now above 80 decibel, it will be considered as noise, or will it be considered as music?
Noise.
Noise, no? So a loudness above 80 decibel, it will become painful. Physically, the sound will become painful. And if it is above 140 decibel level, then the sound will be hurting too much. It will be hurting too much. Usually, if a jet airplane is taking off, at that time, 130 decibel of loudness is produced. But if it is 140 decibel, it will be very painful. It will start to hurt the ear. Okay. So that is one thing. Okay. Also, you guys tell me, what are some of the applications of the ultrasound? What are the applications of ultrasonics? Where is it used? Yeah, like it will be used in a diagnostic or diagnosing several diseases in the human. Where like there are some diagnostic tools now, like a ultrasound scan with the help of
Sir,
this. Mhm.
sir, in communication and medicine.
In the field of medicine, in the field of communication also it is used, or in it is used to measure the depth of the sea or the oceans now, right? How like at what depth a particular like for example, if a submarine sinks to the bottom of the ocean, so how we will be able to locate it? With the help of the sonar, we'll be able to locate it now. That is one thing. Ultrasound is also used in the treatment of some muscular pains also. This point you guys can write it down if you haven't noted it. Also, I'll be providing the PPT of this after the class. So there you guys can add it.
So
That
what
if,
happens in ultrasound?
repeat again,
What happens in ultrasound?
what happens in ultrasound? Basically, if a sound has a frequency more than 20,000 hertz, so thereby that is ultrasound. And what basically happens here, take a look at this here. So ultrasound is being produced here by some source of sound. It will be hitting that object and then it will be reflected back from the object here. So based on the time it will take to go and hit the object and the time it will take to return, based on that we'll calculate the distance. Okay, now, and then we'll be able to locate the distance between the object and the sender. So this will be helping us in finding the depth of the shipwrecks or the depth of the ocean. And in the case of the imaging of the body parts, so thereby, as it will be passing, as it will be reflecting from the soft organs of the body, soft tissues of the body, so thereby images will be produced, and thereby we will be able to investigate inside of the human body. Or also it will be helping us in studying the growth of the fetus inside the mother's womb. Another thing was I was telling you guys about the arthritis. So arthritis is basically when pain develops